I made sure you guys saw it right before you left.
That is easy.
And we talked about eccentricity at the beginning of class. Either way, you can go ahead and write down the formula really fast. That way you have it. 1 more minute.
How much were we supposed to have done? All of it? Like,
The majority, maybe a couple questions.
of 7. What are you spot checking today?
10.3, and for the few that were absent on Friday, also 10.
Oh, I only. Oh, I only did 1 and 2.
So you can have a question.
We couldn't do the last stuff because there was no eccentricity. We didn't know any eccentricity, so I missed like.
You couldn't look in the. You couldn't look in the book and get E equals C over A.
Oh no, I couldn't. I have
Or remember it from class. But I do give that little percentage just to kind of help you guys in the sense that you could have a couple questions that you could not have that you might not have been able to remedy. I do believe the majority of the time the questions you have with a little bit more grit, perseverance, and research might have been figured out, but
What is it for a circle? What's a grid? Is it always going to the same value, right?
A equals 0. Because there is no C, because there are no separate formula. Does that make sense? Getting the spot check ready. Sorry, guys. All right, we have it.
Yep.
Pretty close.
Yeah. You know my dogs.
No, can you see the thing closer? Alright, relax. Can you zoom in a little on the graph?
The long story short of the graph, remember, that note up above says that E. Alright. Not anymore. The note up above says that E can only go between 0 and 1. If E was 0, these foci would be on top of the center, and that would be a circle. And that would be a circle. E cannot go beyond 1 because the C, the distance to the foci, can't be any bigger than A. And if it does equal A, it's going to be flattened all the way, so it would be a line. It wouldn't even be an ellipse anymore. But the closer E is to 1, that little fraction, that ratio, the closer it is to 1, the more distorted the ellipse. And then the smaller E is, or the closer it is to 0, the more circular. That's all it is. That's the idea of eccentricity. Alright, we should be pretty close. I'm going to have you guys actually just go straight into 10.4 because once again, since it's a new conic section, we're talking about hyperbola today. Because we're talking about hyperbola today. And we're in a new section. We have some things to draw, like we have sketches, we have labeling of the sketches, and we have our standard form equations to make.
Oh,
So it's going to take a little bit of time. Yeah.
so this is the last part of 10.3?
Yeah. There's nothing else in 10.3. It was just that one little E equals C over A and understanding the smaller E is, the more circular, the bigger E is, the more elliptical it is.
Understand.
Alright, as we go to 10.4, I'm going to go ahead and come around and spot check. I do say at 75% because I understand that you might have a couple of questions that you need answered. I'm going to go ahead and come around and spot check now, so I want you guys to stay in your notes. Then we'll... There we go. I want you guys to stay in your notes and just keep going. And then that also gives me a little bit extra time because I know a lot of people were gone on Friday, so I have like excuse of I'm going to check their 61 as well. So I'm checking homework 10.2 for those of you guys that didn't have it ready on Monday. Either you were late on it and you're trying to get half credit, or you were excused on it because you were absent, you're showing me it in. And then 10.3. Ready, set, take notes. I tried on my phone last night, didn't have my computer up, and it didn't let me save. Maybe 1.5. If you keep going, out of 5. If you keep going, you get half the half credit.
Is it going in homework?
Yeah. Okay, but can I see it? Can I see your 10 too also? Okay. I think you showed me this. Yeah. Yeah, good. You guys ready for me to scroll down? Okay, can I scroll part down? The definition is so tiny because we're not going to use them a lot. You're not going to have to memorize them a lot. I'm going to talk about him real quick, but he's not going to be a huge idea. Oh, you still haven't got the definition? I checked like 5 kids. What you guys doing? I checked more than 5. I checked 8 kids. JJ.
So difficult to see. That was a mistake.
It appears to have been.
Yeah, he was like, Jeremy, you should have done that. Set. So what does that mean? He like spotted it?
You guys should be pretty close.
I don't even know that was Oh my gosh, there's so much to do.
That's toilet paper, bro.
It's so nice. You're rushing, it happens.
Makes that big of a difference?
What's the small one? The small one? A.
I don't know, Caleb. That looks like a G and a D. The small one? Looks like the C is the big one and the G is the small one. But I think that's
Yeah, 16.5.
correct. I know, I'm actually gonna go up to.
No, I'm gonna go first. I wanted to go. No, I got up first.
Oh, that is an A.
Oh, wow.
Word. Alright, A. Okay.
I don't even know if I'm
I feel like sitting in front of Bruce.
That one's A's.
Yeah, I did. Alright, kiddos, open up your homework spirals to 10-3 and a colored pen. We're going to grade it.
Oh,
Alright, how many of these are sophomores? Yeah, they're doing their pre-ACT thing today. Abby's a junior though, right?
No.
Naomi's a sophomore?
yeah,
Wow. You can tell I don't look at your guys' papers. Like what?
Yeah.
Okay, sophomore. Maddie's Fuller is a sophomore, right? Ashley's a sophomore. Mason's a sophomore.
I never thought it was gonna happen.
Naomi's a sophomore. Oh, there are a few sophomores.
Mrs. Reagan brought me our lasagna for biotech class, and Colden made meatloaf.
Go fast. Alright, cool kids, here we go. Evens, let's go ahead and check them. And I saw a few of you guys that had at least a couple questions. Eccentricity, we have the formula now for, but you might have other questions as well. So, let's go ahead and, here we go. Number 6 should have been C. Number 8 should have been D. Number 14 wasn't matching. Let me go ahead and zoom in just a little bit. My chatterboxes. Okay. 6 is C. 8 is D. Number 14, final answer should have been x squared over 25 plus y squared over 21 equals 1. Sorry, it's in the shading. X squared over 25 plus y squared over 21 equals 1. Number 26, x minus 2 squared. This is, I don't know, this one might help you more. Because this one, the second to the last step, shows you the 1 squared that's being put in, that was your B. And the 3/2 squared being put in is the A. This one down here is just a simplified version, like what I did in class with the 9 over 4, and then you flip it. And then the 1 they just didn't write because it's over 1, it stays the same, we're good. So x minus 2 quantity squared plus 4 times y plus 1 quantity squared all over 9 equals 1. Huh.
Instead of putting 4 9s, because you have just put,
9/4 down there.
oh yeah.
Yeah, you could have done that. Or you could have multiplied both sides by 36. Or, I guess, just by 9. Justin.
Why don't they show some like really simplified version where it's like
They allowed you guys they were actually being kind of nice. They were allowing you guys to, alright, focus. They were allowing you guys to stop at that shortened, like, shortcut by hand version. So they didn't make you go all the way. Now, in the directions, technically, if you had read them carefully and saw the standard form and gone all the way, that's great practice, but they didn't make you go all the way. They were trying to help you out, basically. And number 38, They gave you the equation that was like the example that I made up yesterday. It was a lot like that one. They gave you the equation. You had to go in and graph the ellipse. So the different pieces, the center was -3, 2. You can see it here in the graph. The vertices ended up being A was 4. So you add 4 to the y's because the major was on the y. So add 4, subtract 4, you get the points -3, 6, and -3, -2. For the foci, you have to find C. Add and subtract from, once again, the middle point. Eccentricity, some of you might have gotten a little confused. Just take the C, which is 2, and divide by the A, which is 4. And 2 over 4 is 1/2. Ricky, what was your question? Kind of, or you can do it tonight. And then over here, number 48. He was gnarly. How come? You have to complete this one. But we did an example like that yesterday to try to help with completing the square. In that, you group the x terms together, pull out the 9 that's in common, group the y terms together, pull out the 25 that's in common. Fill in that blank, add the 2 on the other side that correspond to what those values really mean. Simplify. The gnarly or the hard, completing a square is not fun. But taking this 9 over 1 and 25 over 1 and making those denominators was also not fun. That was also kind of complicated. I would totally expect probably half of you to get stuck on that step, hence why I'm trying to point it out. 9 over 1 can become 1/9 in the denominator. That way you have an A. A is 1/3. Square rooting that. 25 over 1 can become a 1 over 25 in denominator. Square root is 1/5. That's why this ellipse down here, let me get rid of this writing, sorry, is a little itty bitty guy. A little baby one. See, he just goes out. A was what, 1/3? He goes out 1/3, and he goes back 1/3, hence why he has these fractional x's. So 2 plus 1/3, 2 minus 1/3. And then the foci, you had to use your C, which ended up being something nasty, 4/15. So you add 4/15 to 2, and then you subtract 4/15 from 2. Eccentricity, plug and chug. Little baby guy. All right, a couple more seconds because I know those last ones some of you guys want to write down and make sure you can get it on your own later. But let's get back to notes as soon as you guys are able. Let's put away those homework files. Oh, there he is. All right. Our goal today is hyperbola. The last of our conic sections, sadly. Or maybe not sad at all. So far we've had a line, he's a degenerate. We've had a parabola with directrices and foci. And we've had, are you spying on people outside?
Huh?
So are you spying on people outside?
Yeah.
Parabolas, ellipses, hyperbolas, it's time to go. The definition at the top, which I said wasn't a huge deal. Hyperbolas is, I don't know, they have their own gnarly definition. That's like the word for today, I don't know why. Ellipses, I'll start with circles. Circles have a radius, go all the way around with the compass, there you go. Parabolas have that snazzy from the focus hitting the parabola going down to the axis of symmetry, how that is congruent, that's a parabola. Ellipse has the 2 foci, and think of a string, you can go around and you'll make the ellipse instead of the circle. Hyperbola is this other form where you go from one focus to a point on the opposite branch to its focus on the same branch. That subtraction absolute value is constant. That's literally the definition, but that's a complicated definition. Even how to draw that, I don't know. So it is the definition, I just put it there so you guys can see where a hyperbola comes from, like what those shapes are defined by as far as distances, but that's not where we're going to spend our time. Where we're going to spend our time are on the graphs, the pieces of the graphs, the equation that go with it, and the equations that help us in finding each of the different components that we might be asked, okay? So, what do you see in this equation that's different than an ellipse? That's the one difference. One little baby difference comes up with a whole different graph.
You just go down a tiny bit.
One baby difference changes a lot of the graph. Now, the nice thing is, because there's only one baby difference, a lot of things are going to be fairly similar. Like, the h and the k that we already know being the center is going to be the center for the hyperbola. So the h and k that we already know, just like it's the center of an ellipse, it's going to be the center of each of the hyperbola, whether it's vertically or horizontally oriented. The vertices that we're used to extending on the major axis, okay, this is different. The vertices that we're used to extending on the major axis, the major one being whichever denominator is bigger, that changes. Since we have subtraction, that's what's new. Since we have subtraction, the orientation, horizontal or vertical, is based upon what term is positive. So if you guys notice, the first term on the first one is the x term, and the hyperbola, everything is happening on the horizontal. The second one, the y term, is positive. If you notice, everything is happening on the vertical. So another key difference, besides just the subtraction, is in an ellipse, the x always comes first, the y always comes second, no big deal, everything's positive, it doesn't make a difference. But with hyperbola, not quite the same. With hyperbola, whichever term is positive, whichever term comes first, that's the one that determines. It doesn't matter the size of a and b. Who knows? Sometimes a is bigger, sometimes b is bigger. It's not the major or minor. It's all dependent on who comes first. So I'm going to put a little who comes first or who's positive. Who's on first? Are we going back to?
No.
I think so.
Wait, what?
So Dr. Singles is on second.
Who's positive? So the ellipse, who's bigger in the sense of the major and the minor? Hyperbola, who's first? Besides that, once we figure out who's first, like in this top one again, the horizontal transverse axis, then horizontally, we go the a distance, which is the same thing as before, to the vertex, and then we go the c distance, which is the same thing as before, to get to the foci. But we're going to also go to the right and to the left as we did before as well. We're going to extend both directions like we did with the ellipse. All it's going to change in the second one, if we have the y first, we're going to instead go the a distance down and up instead of right and left. And then the c distance, we're going to go down and up instead of right and left. That's all it changes. That's all it changes. So let's go ahead and fill in those formulas then. For the vertical, what's going to be the center, guys? HK, same thing. No big deal, yeah. So HK is the center. Vertices. How do we get to the vertices? Do we add to the x's like up above, or do we add to the y's? Yeah, so up above we're adding to the x's because it's horizontally oriented. This one's vertically oriented, so we're adding to the y's. It's very similar, just we're doing k plus or minus a instead of h. So following that pattern, what do you think is going to happen to the foci?
They're going to minus c.
Yeah, the x is going to stay the same as well, and k is going to add and subtract the exact same c value. Okay, so all different. Horizontal one, you're adding to the h's for the vertices and the foci. For the vertical one, you're adding to the k's. Once again, my formula people, if you love formulas, alright, start studying them. You have all spring break, study them down. Not that you should use all that time for formulas. I'm just saying. You have a little extra time to try to get formulas down. For those of you guys that are visual, maybe we can get a visual feel like we did for ellipses and parabolas. One other thing has to change. Ellipses said C is less than A. A says go to the edges of the ellipse. C says go almost as far, depending on the eccentricity of the ellipse. But for hyperbolas, no. We're not going a smaller distance to the foci, we're going a bigger distance. We have to go outside the branches because the parabolas extend in opposite directions and the foci are past the parabolas or past the vertices. So maybe that helps you get some sort of point of reference to studying for foci of hyperbola is not minus, it's plus. C squared equals a squared plus b squared. But there's one more important part to do with these hyperbola. If you guys have ever graphed a hyperbola before, I'll come back. I promise I'll come back. But down here, we have the foci, we also have the asymptotes. Does anybody see any asymptotes in the graphs up above? Where are they? I'm going to go ahead and do a gray, just to go ahead and show that. We go through the center, and there's slanty asymptotes, like we saw earlier on this year. But instead of having to do all that crazy polynomial division stuff, we're going to be able to find them another way using some more of the clues in our equation. So the asymptotes, they don't actually show up in a graph. You guys realize asymptotes don't actually show up in any graphs, meaning if you were to graph in a graphing calculator, most won't show you, they'll just be absent, but you'll see what they do, how the graph skins them. So unlike a parabola that extends forever, hyperbolas are restricted, they're held in a finite space. So they keep on going, but they're going to keep skimming that asymptote. They're not going to extend beyond that. But to find the asymptotes, well, to find any lines, right? To find the equation of any lines, we need y minus y1. Hey, what is this, guys? Point slope form. We need a point and we need a slope. Wait a minute, hold on. What point are all of these asymptotes going through? The center. Oh, okay, so we don't need x1, y1, we can just use hk instead. The point where they are going to intersect, the point that we know for sure they are going to hit, we're going to put hk instead. H goes with the x, k goes with the y, like we're used to. But the question that we need to answer is, okay, so we can use hk for the point, but how do we find the slope? That's what we have formula for. Slope does equal rise over length. And there are going to be two different lines, so we're going to actually do plus or minus, plus or minus. And if you guys notice, and maybe you don't even necessarily, but I'll try to show it in the graph, even though it's going to make it sadly kind of messy. The slope of one of the lines, and hence the negative slope of the other line, is going to be, what's this distance, guys, from the center to the vertex? What is that called again? A. And what's going to be the distance over? Although, I wonder if the letters really changed. A. Okay, A did go with Y, right? And B went with X. So in this one, it's okay to say A and B. Are the letters going to change at all when we go over here to this top picture? I'm going to go ahead and go over, and I'm going to go up. Isn't A the horizontal this time? Isn't B the vertical this time? So here's the trick. It kind of depends on which way the hyperbola is oriented. I'm trying to get it to where you guys can see the picture and the formulas at the bottom. It's really small. There are technically going to be two different types of rise over run. So what I'm thinking is, instead of drawing it down here below, since there are two different types, let's put it up above where the pictures are. And let's say the slopes of the asymptotes for the top one is going to be plus or minus b over a. And then this bottom one is actually going to be plus or minus. We still need rise over run, so it's actually going to be a over b. Now that looks really confusing unless you realize, guys, who always goes on top? A letter? No, the letters change. But what does that letter go along with? Maybe. I was thinking a little bit easier than that though. I was thinking, what does it always go along with? The y term. It's whatever coefficient goes with the y. Oh, changing y over changing x. Maybe that makes sense. doesn't matter the letter, it matters the number that you choose. You choose the coefficient for the y term over the coefficient for the x term. But I thought I'd give you the little formulas just in case you guys need to see them. Is there anything anyone needs me to zoom in on? Because there's a lot of really small stuff. Do you want me to zoom in on slopes? Zoom in down below.
Can you go back down to the slope?
I'm saying the rise over the run, so if it helps, we can say plus or minus, and you go ahead and write it out. Right. Program keeps working. Plus or minus. I'm gonna say delta y over delta x. It's not always b over a, it can be a over b, it just depends. But it is the coefficient, the denominator of the y term over the denominator of the x term. That's always true. Alright, pause. I know it's warm. I know I have to talk through all sorts of details. We're going to get to examples. We get to start working things out. You guys can start answering questions, etc. But everyone in the room needs some sort of high five because we have people literally asleep on their desks. Ready, set, go.
I'm not
You're not? Are you sure?
Yeah, I'm listening. I'm just not asleep.
Yeah, Jake, where are the donuts?
I was praying.
Yeah,
No,
Jacob.
For no reason at all.
No way!
Alex is right
Chill.
there.
No.
Alright, here we go. I know.
No?
Here we go, it's example time. Woo, we got that whole page of all this detailed stuff.
Who's Jason?
Help me out.
Oh, we go to 45.
It's always on Wednesday mornings. It just stays all nice warm and cozy for a while. The very first thing. No words. Alright, you ready? Do a true sign we're upperclassmen because we're all tired and not wanting to do anything.
Yeah, let's just take it down.
I'm here.
When you have clues! Yes, I'm yelling because people are talking. Shh.
So close to the mic.
It's okay, they'll have fun video. When you have clues. I'm projecting this one. What's the very first thing I say you should do?
Make a graph.
After you have them written down. Make a what? Make a what?
Graph.
Sure? Make a what?
Graph with the capital G.
No! Oh, I thought you said a capital calculator. I was like, Okay. So, do you guys know how to graph points?
No.
Oh, come
Yes.
on. Maybe? It's not bad of a day, huh? 1 and a 2 and a 3 and a 4 and a 5 and a who knows what else. And a 1 and a 2 and a 3 and a 4 and a 5 and a who knows what else. Okay, so we have foci where? Negative 1, 2, and 5, 2, right? Alright, foci. Think about the picture of a hyperbola. Foci are the little points that the parabolas are eating. Does this make more sense if we have horizontal ones or if we have vertical ones? Horizontal ones. Because it's in the same, if you think about it, it's in the same horizontal line. Wait, but we have vertices too. Where do those go? Does it make sense that our hyperbolas are somehow going like that? Not exactly how, but somehow like that. Look at your formulas. If the hyperbolas are horizontally separated, is that an x term first or a y term first? Okay, so we need to fill into the x minus somebody squared all over minus y minus somebody squared all over equals 1. True? And technically, maybe we can erase some of this over here to make more room. Usually the easiest thing to plug in is HK, right? We don't have it. But we do, because what do we know about the line that all of these are on? What's the transverse axis? It's horizontal. What equation is it? 2. So the y value is 2. We know that already, so we can plug in k. K is 2. What's the h?
2.
How do you We have 4 and we have 0, and we can go in the middle of 0 and 4. And what's the middle of 0 and 4?
2. No, 2.
Struggle.
2.
So we have a center of 2, 0, right? No, not 2, 0. We have a center of 2, 2. Okay, so with our center of 2, 2, we have our H, we have our K. What else can we fill in? Any ideas, guys? Look at your pictures. It gets a little confusing at this point. We have an A and we have a B. Here's our horizontally oriented one. Okay, we get my little pointer out. We know the X term comes first. We got our H, we got our K. How do we find A? Oh, the distance between the center and the. Oh, okay, so hold on. Look at your picture.
2.
Yeah, it's 2. The distance between the center and the vertex. We know that because the whole distance is 4, so half the distance must be 2. Right? Some of you guys are judging my little tick marks. I guess suppose I kind of am too. Blame the tick marks. Nathan's asking good questions. Anybody have an answer for him? Because we found A. Just fixing my tick marks on distraction. We found our A. How do we find B? Use the foci thing. Wait a minute. How do we find C? A squared, okay. So A squared plus B squared is C squared. That's a formula, true? What can we plug into that? We have A. What else do we have?
C.
What is C?
3.
Center to foci. So center to foci, we're trying to find this guy. 2 is to the vertex. 3 is to the foci, according to the point they gave us. And we can check that out, kiddos, because you can look at this and say, hey, I have a 5. I get to 5 from 2. How much do I need to jump? 3. Or you can look on the graph and actually count the tick marks. And be like, oh, sweet, it's 3. So I have 3 squared.
I think B is 3.
Oh, we don't know B. We know C.
But Caleb thinks B is 3.
I thought
But it's
C is,
not.
C is 3. I read the file wrong. It's, I'm tired.
B squared is 5, right? B would equal square. Wait. But do we need B squared or do we need B?
Squared, so that would be fine.
If you want, you could go ahead and solve for B and get B is square root of 5, and then you could say, what is B squared? Square root of 5 squared. But if you notice that we just need the B squared, maybe you can just steal and then not even go that nasty square root direction, I suppose. Oh wait, are we done?
Yes.
Oh, go team. All we gotta do to finish is just like suppose, say that 2 squared is 4. So we're getting used to a new conic section, but we have to just keep in mind the pictures, the diagrams, the A's, the B's, the C's, the H's, the K's, and the standard forms of the equation. Let me give you guys one and let's see how far you can get. I'm not saying you can find everything because this whole passes through the point is a little tricky. You guys saw it in the ellipses and the parabolas, I think. Parabolas for sure. But start with the graph. Draw your graph. Figure out, does the X term go first or the Y term? And let's see what you can plug in. You should be able to get the center. You should be able to get A. You might just get a little fuzzy after that. Ready, set, graph your points.
Are the foci always one away? Or no?
No.
Okay.
Good idea, but no. It depends on how narrow or wide the branches of the parabolas are.
Okay.
Does that make sense? Or
Yeah.
the branches? So all my sophomores are going, but everyone else should be. What'd you guys figure out? Should the X go first or the Y go first?
X.
Yes, I agree. They didn't mark any of the sophomores. While I'm back here, I'm changing that 100-point thing on your guys' test.
Did the people who got like higher scores get over 100?
No.
I don't think anyone got over 75.
The heck, really?
Yeah, because she put it in on 100. So if you get 75 points, she said 75 out.
75 points is 100 because it was only out of 75 points. So I'm just changing the points real quick because I showed it as out of 100. Yeah.
Oh, so is that why my grade went down?
Yes.
Oh.
Yeah, I went down with the like, I got pretty good on the last test.
You're really not letting me change.
Alright, take the test off. Revert all changes.
Guys, I'm randomly changing the date of your test because it's not letting me change if it was last grading period. I figure you don't want it out of 100.
No, not really.
So randomly, we had the test on April 3rd now.
Yay!
I'm rewriting history.
If anyone asks, April 1st, yeah.
I can't because the new grading period didn't start till the 3rd.
Oh, my Misty!
It would be funnier.
I know.
We can't even lie, right?
Okay, so test scores should be better now. Go ahead and check them out. Your RenWeb was a little bit distorted for a while, and I apologize.
I was worried.
I know.
My grade went down 10%. I got 90.
Okay, where did you guys get the center to be?
0,
0.
2, 0, 1.
0, 1.
Told you.
That is hideous.
I know it is hideous. I totally agree. I somewhat agree with them. It was judging, but I don't think it was harsh judging.
I mean, it was.
Maybe the hideous attitude was a bit uncomfortable. That's okay. So we have -2, 1 and +2, 1. And so if you guys figure out your center was halfway in between, hopefully you started filling into your formula. X minus, that's the point 0, 1. 0. Minus. You guys alright? Who's A?
2.
Yeah, count the distance, right? Count the tick marks, not a big deal. Count the tick marks, then we have 2. So then 2 squared. How do I find B?
Yeah.
None of us fell. Oh, wait, it's C.
We don't have C, they don't tell us about foci. They tell us about this random point in the middle of nowhere. Like, what's with 5, 4? 1, 2, 3, 4, 5.
Oh, you can do the thing.
Like, what's going on there?
You can plug in
Wait, but how does that get us the foci?
Well, we don't know B, we don't know our foci, so we're just gonna write B squared. 5, 4, isn't that an X and a Y?
Plug it into that one.
So can't we plug in, hey, well I'm gonna make this prettier first. We have X squared all over 4 minus Y minus 1 squared all over B squared. But then I can go ahead and say, hey, let's plug in this 5 as X. Let's plug in this 4 as Y. Now it's going to be messy, but if we plug in 5 for x and 4 for y, aren't we just missing b?
Yeah.
Then we'll have b, we'll plug in truncate, we'll be good to go. Does that make sense? So then we have 5 squared, which is 25, all over 4, minus 4 minus 1 is 3. 3 squared is 9. I'm doing a little mental now. Equals 1. This is a little bit messy to think about common denominators, unless you think of my really cool trick of multiplying both sides by the common denominator, which in this case would be the 4 and the b squared. And when we distribute, the 4 is going to cancel, so I have 25b squared. Minus the b squared is going to cancel, so I have 36. And I have 4b squared over here. And now it's an algebra game of getting the b squareds on one side. I can subtract. Getting the numbers on the other side.
How'd you get 216?
221b.
Oh, it's 21b.
Oh.
I'm going to make it a b instead of a 6. It's 21b. So divide by 21. Divide by 21. B is equal to 6 over 21.
Sounds good.
Couldn't we just say forget it? All we want is b squared. So couldn't we take b squared equals 36 over 21 and say, oh, you know what? We're just going to plug him in and say, yay, we got it, we're done. So I'm going to write it over here to the side. We have x squared all over 4. It's okay if you guys go. Homework is technically due the Monday after break, but some of you are like, I'm not going to do it then. What should you do tonight then? Finish it as much as possible because who wants homework? Bye, cool kids. See you later. Good job, guys. You're welcome, David. You had record, right?
Yeah.